Okay, picture this for a second. Every phone charger you own, every laptop brick, every data center humming away somewhere to keep your favorite AI chatbot alive, all of it runs on tiny switches that flick on and off millions of times a second. And for about 70 years, those switches had basically been made of one thing: silicon. Silicon built the modern world. I'm not exaggerating, but here's the part that genuinely fascinates me. Silicon is running out of road. It's smacking into a physical limit it just can't cross. And a company most people have never heard of, started by a former NASA scientist, is quietly ripping silicon out of the guts of our electronics and swapping in something far better. That company is Innoscience. By the end of this video, I think you'll get why the biggest names on the planet, including Nvidia, Google, STMicroelectronics, are all lining up at the door. If you're into the stories that are actually going to shape the next 10 years, do me a solid and tap subscribe now, because this is exactly the kind of thing I dig into on this channel. Alright? Let's get into it. So, what actually is gallium nitride, and why should you care? Gallium nitride is what engineers call a wide bandgap semiconductor. I know that sounds like jargon, so let me put it in plainly. Compared to silicon, gallium nitride can handle higher voltages, run hotter without melting down, and switch on and off way faster while wasting far less energy as heat. That last bit is the whole ballgame. When a switch wastes less energy, everything downstream gets better. Your charger shrinks, your device runs cooler, your electricity bill drops. And in a data center, those tiny savings multiply across thousands of racks into something enormous. Honestly, the first time I really understood this, it clicked why the industry has been buzzing about gallium nitride for years. It's not hype, it's physics. Silicon has been squeezed for every last drop of performance, and there just isn't much left to squeeze. Gallium nitride, on the other hand, has tons of headroom. It's like watching a runner who's been maxed out for decades get passed by someone who's barely warming up. Here's where it gets personal though, and honestly kind of inspiring. Innoscience was founded back in December 2015 by a woman named Luo Weiwei, and her backstory is wild. Before she could ever touch semiconductors, she spent 15 years at NASA. She earned a PhD in applied mathematics in New Zealand, and then worked her way up at NASA's Marshall Space Flight Center, eventually becoming a chief scientist working on rocket fuel technology. Rocket fuel. Then she walked away from all that, moved back to China, where she's originally from, and bet her entire career on gallium nitride. People in the industry called it a no man's land, the kind of thing insiders were too scared to attempt, and she said that her years at NASA gave her the courage to explore places nobody else would. I love that, because what she built is not a small thing. In under 6 years, Innoscience became the first company in the world to mass produce 8-inch silicon-based gallium nitride wafers. That's a genuine engineering milestone, and they got there first. Now, why does this wafer part matter so much? Well, because this is where I think Innoscience is really clever. Most gallium nitride startups grow their gallium nitride on tiny, expensive specialty wafers. Innoscience instead grows gallium nitride on a standard 8-inch silicon wafer, the same size and basic material the entire chip industry already uses. That's the secret sauce. It means they can produce gallium nitride at a massive scale and low cost using infrastructure that's already mature, and it shows in the pricing. Reports suggest Innoscience's prices run close to 50% below their competitors. 50%! In the chip world, that's not a discount, that's a wrecking ball. It's a huge part of why they're rocketed to the front of the pack. By 2024, Innoscience held roughly 30% of the entire global gallium nitride power device market, more than any other single company. They've shipped over 1 billion gallium nitride chips, and they run what's called an IDM model, meaning that they design and manufacture everything in-house, which gives them tight control over quality and cost. As someone who loves a good underdog to leader story, this one really does it for me. But let's talk about the thing that's really lighting a fire under this company right now, because it's the AI boom and the connection is more direct than you'd guess. Here's the problem. Modern AI data centers are absolute power monsters. A single rack packed with GPUs can gulp down staggering amounts of electricity, and the old way of delivering that power, a 48-volt system, is basically hitting a wall. Innoscience has pointed out that in those legacy setups, more than 45% of total power can get wasted on just removing heat. Let that sink in. Nearly half your energy gone before it does a single useful calculation. So the industry, led by Nvidia, is moving to a completely new architecture called 800-volt DC, and the logic is beautifully simple. If you crank the voltage from 48 volts up to 800 volts, the current drops by about 16 times. Less current means less heat, less wasted energy, and dramatically less copper wiring. It's the same reason electric cars jumped from 400 volts to 800 volt systems. And here's the kicker. To pull off that 800 volt jump, you need switches that can handle high voltage and blistering speed in a tiny footprint. Silicon basically can't do that anymore. Gallium nitride can. This is Innoscience's moment. They've built what they call a full link, all gallium nitride solution, meaning that they can supply the chips for every single stage of the power journey, from the 800 volts coming in all the way to the roughly 1 volt that actually feeds a GPU core. They're the only company offering gallium nitride for the entire chain, and the performance numbers are really impressive. One of their showcase designs, a 12 kilowatt converter, hits around 99% peak efficiency, all while running at a blazing 1 megahertz switching speed. Their third generation gallium nitride reportedly cuts switching losses by half compared to silicon carbide, which is the other big alternative material. That's not a minor tweak. That's the kind of gap that decides who wins. And all of this is exactly why the giants came knocking, and the list is honestly kind of stunning for a company that's only about a decade old. In early 2026, Innoscience announced that it had completed design-ins for Google's AI hardware platforms and also signed a formal supply agreement with them. Google. Then there's Nvidia. Innoscience is the only China-based company on Nvidia's list of approved suppliers for that 800-volt architecture, and at Nvidia's big GTC conference in March 2026, Nvidia actually handed Innoscience a GaN Supplier Award. Founder Luo Weiwei was photographed alongside Jensen Huang himself. STMicroelectronics signed a development deal to build next-generation gallium nitride together, and onsemi, a major American chip maker, signed an agreement to tap into Innoscience's manufacturing. Think about what that means for a second. Established Western giants are essentially partnering with the company to get access to its gallium nitride production. That tells you everything about who's actually leading here. Now, let me hit you with the numbers, because 2025 was a turning point. Innoscience's revenue jumped about 46% to roughly 1.2 billion RMB. But the number I care about more is this. Their gross margin flipped from deeply negative, around minus 19%, to a positive 7.3%. In plain English, for the first time, they started making money on the actual product itself instead of bleeding cash on every unit. For a hardware company scaling up something this hard, that's a massive signal that the business model works, and analysts are wildly bullish, with some projecting the company's revenue could compound at more than 70% a year through 2028. That is rocket ship growth, which feels fitting given the founder's background. Now, I want to be fair and give you the full picture, because it's not all smooth sailing. Innoscience has been tangled in patent disputes, most notably with the German giant Infineon, which secured some favorable rulings in 2026 that could complicate Innoscience's access to the US market. There are also real geopolitical tensions, since Innoscience is a Chinese company operating in a technology that the US considers strategically critical, and China controls much of the world world's gallium supply. So there are genuine risks here, and I'm not gonna pretend otherwise, but even with all that hanging over them, the demand for their chips keeps climbing, and the technical lead they've built is real. My honest take, betting against a company that's cheaper, faster, and already inside Nvidia and Google's supply chains seems like a tough position to hold. So where does that leave us? Well, I think we're watching one of those quiet revolutions that history only recognizes in hindsight. Silicon ran the show for 70 years, and it had an incredible run, but every technology eventually meets its ceiling. Gallium nitride is the material carrying us into the AI era, into smaller charges, into electric cars, into data centers that don't cook themselves alive. And Innoscience, born from a NASA scientist's refusal to play it safe, has muscled its way into the very front of that shift. Is it a lock? Nothing's a lock. But if I had to bet on who's genuinely reshaping how the world moves electricity around, they'd be right there at the top of my list. And I find that genuinely exciting. And if you've got something out of this, smash that like button because it truly helps the channel more than you'd think. And subscribe so you don't miss the next deep dive into tech quietly rewriting our future. I've got a whole lineup of these coming, and I'd love to have you along for it. Thanks for watching, and I'll catch you in the next one.